Hello and welcome everyone. In the last video, we discussed about the concept of time value of money, compounding technique. We discussed the cases of calculating future value of a single present cash flow and future value of a series of unequal cash flows. In this video, we will be discussing three other cases of compounding technique, that is future value of a series of equal cash flows, that is future value of an annuity, future value of an annuity due, and future value when compounding is more than once in a year. In the context of time value of money, an annuity refers to a series of equal cash flows or payments made or received at regular intervals. These cash flows can occur annually, semi-annually, quarterly, monthly, or any other regular interval. Annuities are a fundamental concept in time value of money and are discussed and used in various financial calculations, including investment analysis, loan amortization, and retirement planning. There are two primary types of annuities: ordinary annuity and annuities due. Ordinary annuity. In an ordinary annuity, the cash flows or payments occur at the end of each period. For example, if you have an ordinary annuity of rupees 1000 per year for 5 years, you would receive rupees 1000 at the end of each year for 5 years. Annuity due. In that case, the cash flows or payments occur at the beginning of each period. For example, if you have an annuity due of rupees 1000 per year for 5 years, you would receive rupees 1000 at the beginning of each year for 5 years. Annuities are essential in financial planning because they help individuals and businesses make decisions regarding investments, loans, and retirement savings by considering the time value of money. Understanding how to calculate the future and present values of annuities is crucial for making informed financial decisions. So, in the current video, the first thing we will be discussing is calculating the future value of a series of equal cash flows, also known as calculation of future value of an annuity. So, we have a problem. Mr. X invested an amount of rupees 10,000 each at the end of first, second, and third year. Calculate the compounded value of his investment at the end of third year when interest is provided at the rate of 10% compounded annually. So here you can see you're not having three different amounts for 3 years. You are having the same amount, and this particular fixed amount is invested at the end of first, second, and third year. So this is a type of ordinary annuity. And we are having critical data. So in order to solve that, we will write that first. So the present value is 0. We don't know about it as it's the case of annuity. So we are having constant payments or constant investment. Year is 3, number of period is 3, rate is 10%, and payment is 10,000. That is the fixed amount which is incurred or recurred basically at equal time interval. Future value at the end of third year will be calculated again using the future value function. So we are having this function. We activate FV, and again it will ask us the 5 different items, that is rate, number of period, PMT, that is the constant payment, present value, and type. Now here type is of crucial importance because type will define whether the type of annuity is ordinary or it is annuity due. So rate will be 10%, number of period will be 3, Payment will be 10,000. That is the equal payment for 3 years. Present value is 0 and type is 0, as it is given in the question that this particular amount is invested at the end of first, second and third year. So we will take type as 0. We will enter and we will get 33,100 rupees as our future value. So this is how the built-in future value function helped us in getting the future value of this particular problem as rupees 33,100. Also, the only difference between ordinary annuity and annuity is on the basis of the type. Okay, so whether it's end or it is beginning. So let's first discuss the future value of an annuity due. So it's very simple. You will understand this by a question. So, for an annuity due or for an annuity that is due, the type in the future value function is chosen to be 1 instead of 0, given the payment is made in the beginning of the period. So you will understand this by this particular problem. So here, Mr. X made a recurring deposit of rupees 10,000 in the beginning of each of 3 years, starting now at the interest rate of 10% per annum. What amount he will receive after 3 years? Okay, so here the critical data is that present value is 0, year is 3, number of period is 3, rate is 10%, payment is 10,000. Everything is same. The only difference is the timing of that investment. In the earlier question, when it was the case of ordinary annuity, it was at the end of each year. But in case of annuity due, the recurring deposit is made in the beginning of each year. So here, only the type will change. So we will again activate the future value function, the built-in Excel function. Rate is 10%. NPER, that is number of period of a constant payment, is 3. Payment is 10,000. That is the fixed amount we are paying at, or we are making at equal time interval. And we have inserted a negative sign in order to get the positive value. And B79 is 0. We don't know about it. And 1 is the type, which is very important in this case because it is given in the question that it is the type is the annuity due. So type 1 we will take. Enter and you will get your value. So by using the built-in FV function in Excel spreadsheet, we have calculated rupees 36,410 rupees as the amount he will receive, X will receive after 3 years. I hope this is very clear to you. Now, the last case, in case of the compounding technique, is future value or calculation of future value when compounding is done more than once in a year. So till now we have discussed the questions where compounding was in the annual mode. But what if compounding is done in different modes? Like it can be semi-annually, quarterly, monthly, weekly, daily. Then what will be our answer? And how it will affect the future value given the terms and conditions remains constant. So, since the compounding is more than once in a year, the effective rate of interest will be different from the actual rate of interest given on per annum basis. So here, the first thing that we are required to do is to change our rate and change our number of period into the state that it calculates the future value when the modes are different. So we will be adjusting our rate of interest and number of payments made during the period of investment as per our compounding basis. So if it's semi-annually, we will be adjusting our rate of interest and number of period as per the semi-annual payments. And similarly, when it's quarterly or monthly. So in the first case, if you're talking about the semi-annual case, the rate of interest becomes half of 10%. Why? Because now compounding is just semi-annually, which means twice a year. So we have number of periods as 2, right? So a number of period will be the twice in 1 year. So in 3 years, it will be 6. That is 2 into 3. Similarly, our rate will be half of 10%. That is 10% divided by 2, which is 5%. So the built-in function of future value will be used in order to find out the future value in a semi-annual compounding mode. So here, if you see here, present value remains the same, 10,000, that we have invested rupees 10,000 now for 3 years. Year is 3. NPER, we know that it's the semi-annual nature. So we have multiplied 3 into 2. If it's quarterly, we will multiply this with 4. If it's monthly, we will multiply this with 12. Okay, and similarly, we can do it for bi-monthly, weekly, daily, depending upon what is asked in the question. For rate, we will divide it by the compounding factor. That is, here our interest is 10%. That is when it is compounded annually. But in case it is semi-annually, we will divide it by 2. In case of quarterly, we will divide it by 4. And in case of monthly, we will divide it by 12. So this is how our rate is now 5%. Everything else remains the same. So here, future value function is activated. Rate will be 5%. Our number of period will be 6. Payment will be 0 because there is no constant payment. Present value, now today's value is given to us. So we have taken 10,000 as our present value. And it is given that the question is silent on end or beginning. So we have taken type as 0. If it's the nothing is given to you, you always take the default value as 0 only and enter. Similarly, in case of quarterly, you will multiply the number of years with 4 and you will divide the rate by 4 and you will get the answer. Similarly, for monthly, you will multiply the number of years with 12 and you will divide the rate by 12 and again activate the future value function, insert the proper syntax based on cell referencing and you will get the answer. So here, when the compounding is done in semi-annual mode, our future value is 13,400 approximately. In case of quarterly basis, it is 13,448 or you can say 449. And in case of monthly basis, it is 13,482 rupees approximately is our answer. So basically, to find out the future values for different modes, adjustments are required in rate of interest and number of period, and this will solve your answers. So this is how, and this is where we complete all the 5 cases of our compounding technique. I hope this video was helpful for you. In the next video, we will discuss the concept of discounting, that is the present value technique, and we will also discuss certain cases under it. Till then, thank you for watching.